Okay, today we're going to be talking about extrema. So first we'll take a look at the definition. So if we let f be defined on an interval I containing c, then it's going to appear that two things will happen. One, f of c is going to be a minimum when f of c is less than or equal to f of x for all x in the I. So what this looks like is, I drew a little picture here. Let's say this is y equals x squared. Well, we know that the minimum point right here is x equals 0. Like, okay, well, it's going to be a critical point, but we haven't gotten there yet. So basically what it's saying is at our c point, which here c equals 0 right there, the f of c is less than all these other y values, okay? So we know that it's a minimum. And then again, the other way we can look at it is, let's say if it's a maximum. F of c is a maximum when f of c is greater than or equal to f of x for all x in the interval. So here I've drawn a picture. Let's say it looks something like this. And at our, we know this is a max, so this is our c point. And at f of c is greater than all these other y values. Okay. Now, critical points. Let's talk about that next. If I can find it. Okay, or not. So, if something's going to be a critical point, so if f prime of c is 0, or if it does not exist, like something like this, then c is a critical point of f. So at critical points, we're going to have max and mins, like we see here, and it's very useful in our problem. So let's practice finding critical points. Okay, let's say we are given f of x equals x cubed minus 3x squared. First thing we're going to do is take the derivative. We want to know when is the derivative equal to 0 or if it does not exist. So first thing, f prime of x equals 3x squared minus 6x. Okay, now we're going to set this equal to 0. We can factor it out, 3x times x minus 2. Now we set both of these equal to 0 like we always have. Okay, so we find that x equals 0 and x equals 2. So these are our critical points. Now, we don't know if these are max or mins yet. We can learn how to do that later on in this video. So let's do one more practice problem of finding critical points. Ignore this graph right here for now. Okay, so let's see, f of x is 4x over x squared plus 1. Right now you should be thinking quotient rule because this is what we need to use. Okay, so g is 4x, h is x squared plus 1, the derivative of g is 4, and then h prime is 2x. Okay, so we plug it in like we know how to do. So this is 4x squared plus 1 minus 8x squared over your bottom squared. So now we're going to set f prime of x equal to 0 to find our critical points. So we're basically setting the numerator equal to 0. And we are simplifying negative 4x squared plus x. And then we're factoring out. So here again, it's going to be x equals, x squared minus 1 equals 0 right here. And then we're solving for x. So x is plus or minus 1. And now going back up to this graph, I plugged into the calculator to check our work while we're learning. That's totally fine. And the graph looks like this. So we can see that at 1, we do have a max, so this is a critical point. And then down here at negative 1, we have a min. Okay, now let's look at another type of problem. Okay, when you're solving for extrema on closed intervals, you're going to follow 4 different steps. So the first step is to find the critical points, which is just what we practiced doing. Okay, then we're going to evaluate the function at those critical points. So once we find the points, we're going to plug them into the equation and solve. All right, then the next step is you're going to be given an interval. So let's say this is 1, 2 on the closed interval. You're going to plug in the 1 and the 2 and evaluate. Okay, those are your endpoints. All right, and then the fourth step is you're basically going to determine your max or your min. Okay, So in this case, let's say you had 2 critical points, so you'd have a critical point, and then these two, so you're going to have 4 y values. Out of those 4, the greatest number, that's going to be your max, and then the least is going to be your min. Okay, let's do a problem with this. Okay, let's say it says find the extrema of f of x equals 3x to the 4th minus 4x cubed on the interval, the closed interval of -1, 2. Okay? So if we look back at our steps, the first thing we need to do is find the critical points. So again, we're going to take the derivative first, I'm sorry. Okay, so this is going to be 12x cubed minus 12x squared. And then we're going to set it equal to 0, so we can factor this out. Okay, so now our critical point, 0 equals x minus 1, so x equals 1. Oh, and x equals 0. Okay, so these are our critical points. So our second step was to evaluate the function at the critical points. So we can go back in, and let's see, f of 1, if we plug this point in, is going to be 3 minus 4, which is -1. Okay, then we're going to plug in our next critical point. So f of 0 is 0. Then our third step, we're going to evaluate it at our endpoints. Okay, so here our endpoints were -1 and 2. So let's see what f of -1 is. Okay, so that's going to be -7. I'm sorry, +7. Then we're going to plug in the 2 here. So f of 2 equals a big number, 16. Yes. Okay, so now our fourth step is we're going to determine our max and mins, which are our extrema. So the least number here is -1, so we're going to have a minimum at 1, and the y value is going to be -1 there. And then we're going to have a maximum here. Okay. So always when you do this, go back to the basic steps so you don't get confused, because a lot of times if the function is big with a lot of sines and cosines or whatever, you might get confused. But if you go back, you find your critical points, you evaluate them, and then you go back to the interval that you're given, the closed interval, evaluate those, and then you get all your y values straightened out, and then it's very easy to see where your max and mins are. I hope this video helped you learn about extrema and will help you in your future years in calculus. Thank you.